Hi class, this is course 3, lesson 22, multiplying and dividing fractions. So there are a couple hints that you can use to help you figure out what your whether it's multiplication or division. If you see the word of, generally indicating multiplication, and the phrase how many whatever are in whatever. So how many 1/3 are in 3. That indicates division, and we'll go over a problem just like that in just a minute. First, I want to model fraction multiplication using an area model, and you're going to put this in your notes because you'll have to model with an area model, and if you don't know what to do, that will be tricky. So we're going to do 2/3 times 3/4. And I know a lot of you already know what to do with multiplying fractions. It's just that we need to review and learn this new area model. So however many denominator, or whatever your denominator is, this is a 3, we need to make a box that has 3 columns or 3 rows. Let's see, I'll go 3 rows this time. So this is thirds, and then we're going to make fourths going the other way, and ideally you would draw those lines straight. So we have, this would be thirds here and fourths up there. Okay, so we're going to use red to shade in 2/3 of our whole unit. Okay, so remember that these were the thirds, the rows were the thirds, and we have 2/3 of them. So I need to shade in there's 1/3, and here's the second third. And then this last row would be the third third. Okay, so I shaded in 2/3. Now I'm going to multiply that by 3/4. So remember, these were my fourths. And I'm going to change colors. I'm going to use green now. And so now I need to shade in 3 of these fourths. Okay, so we're going to shade in 3. Okay, there's 3 of the fourths, right? Okay, now, okay, so what we're looking for is the overlap. Okay, and I don't know, not these extra areas, right? Just here where we overlap, where we have shaded both, that's the product. So we have 2/3 times 3/4 is going to equal 1, 2, 3, 4, 5, 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 out of 12. And we know that better as 1/2. Okay. So that's how the fraction multiplication works. Now if we model fraction division, let's divide 2 1/4 divided by 1/2. And what we're trying to do is split or divide 2 1/4 into as many halves as we can. So first we need to represent 2 1/4. So we're going to write, here's one whole, here's another whole, and here is my best attempt at a quarter. Okay, so it's a quarter of a circle. And now we need to divide that into halves. Okay, so if I divide this into half and this into half, now half of a whole, not half of a quarter. Okay, so I would have like this, right? That would be half of this whole circle, even though it doesn't exist. Okay, so how many halves do we have? We have 1/2, 2 halves, 3 halves, 4 halves. And what fraction of a half is that piece that we had? Well, it's half of a half. So this ends up being 4 halves and half of a half. 2 1/4 divided by 1/2 is 4 1/2. and we'll come back to this. I'll come back to this in just a minute. You won't have to write down any more on this page when I come back. I just want to illustrate something else in just a minute. Okay, so here's the rules for multiplying fractions. A common denominator is not needed. You need a common denominator when you add or subtract, not when you multiply. You multiply the numerators, you multiply the denominators, and then you simplify the product. You may simplify before multiplying as long as you reduce one numerator with one denominator. Okay, this should all be in your notes. Let's look at an example. If we have okay, sorry, I paused the recording, and so I don't know where I left off. I'm going to do an example, okay? So if I have 2/5 times, oh, that's my example there. Sorry about that. We're going to do 3/4 times 8. Okay, now this is a whole number. So that looks different, right? But what we can do is write it as 3/4 times 8, and the denominator would be 1. 8 ones is 8 units. So then what we could do, we can either multiply the numerators, 24, and the denominators, 4 times 1 is 4, and then we reduce or simplify, and you should know that 24 divided by 4 is 6. Or we're going to simplify before we multiply. So 3/4 times 8 ones, I can divide out of 4 and 8. I can divide a 4 out. So I can leave that with a 1, and 8 divided by 4 is 2. And then when I multiply, I have 3 times 2 is 6, and the denominator is 1 times 1, which is 1, which is still 6. Okay, now let's take a look at this example that I tried to do too early there for you. What number is 2/5 of 5/12? And I know it says that we're going to multiply fractions up here, but when you see the word of, you should automatically think multiply. So you are going to take 2/5 times 5/12. And again, you can multiply, I'll do this both ways. You can multiply 2 times 5 is 10. 5 times 12 is 60. And then if you reduce, you would end up with 1/6 by dividing a 10 out of both the numerator and the denominator. Or we can simplify before we multiply. So I know that 2 and 12 have a common factor of 2, so I'll divide both of those by 2. And I also know that 5 and 5 are the exact same numbers, so they have 5 as a factor. Remember that when you reduce, you always are left with at least a 1. So 1 times 1 is 1, and 1 times 6 is 6. Okay, so division of fractions. Reciprocals, this is an important word right there, reciprocals, are numbers with the product of 1. So they look like this, 3/4 times 4/3. That's going to equal 12/12, which it will reduce to 1. 3/4 and 4/3 are reciprocals. You're basically flipping the fraction over. Reciprocals are also called multiplicative inverse. Okay, so if it says what is the multiplicative inverse of, you're looking for the reciprocal. So you might want to star that in your notes. Again, when you divide fractions, you do not need a common denominator. You keep the first fraction, you flip the second fraction to its reciprocal, and then you multiply. And I know some of you know that as KCF or KFC, however you remember. Just remember to do it. You keep the first fraction, and then you multiply by the reciprocal. Okay, so you'll see problems like this. How many 1/3 are in 1? And remember, I told you that we would see problems like that. when you hear the phrase how many whatevers are in something, that's division. And you always start with what you have. You have 1, so we are talking about 1 divided by 1/3. These problems, the how many whatevers are in something, especially when the in is 1, that is always going to be your reciprocal. Excuse me. So if we use our logic here, we keep the first, we multiply by the reciprocal. 1 times 3 ones is 3. Well, the reciprocal of 1/3 is 3 ones, which is 3. So if you can remember that when it says how many 1/3 are in 1, or how many whatevers are in 1, it's the reciprocal. Excuse me. But when we talk about, okay, so then if it said how many 1/3 are in 2, you already know how many thirds are in 1. Well, if there are 3 in 1 and 3 in another one, that would be 6. So you would take this number times, it's the reciprocal of 1/3, so 3 ones. So let's use that logic here. How many 2/3 are in 1/4? We start with what we have. We have 1/4. The how many means we're going to divide, and we're going to divide that by 2/3. So we're going to keep the first fraction. We have to change the sign, and we have to use the reciprocal. And then we can multiply or simplify, and I can tell I cannot simplify, so 1 times 3 is 3, and 4 times 2 is 8. Okay, a couple more problems. We're going to do 2 more here. If you have a whole number and you divide that by a fraction, this, remember, whole number has 2 with a denominator of 1. Then you keep the first, but we need to make it a fraction, and multiply, make this the reciprocal, and that's going to equal 6. If you start with a fraction and you divide it by a whole number, remember that the whole number here is 9 ones, so when you flip it over, it becomes 1/9. So this is 6/7 times the reciprocal of 1/9. And now I want to simplify first, because I know 6 and 9 have a factor of 3, so I'll divide 6 by 3 and get 2, divide 9 by 3 and get 3, and then I want to multiply. If you simplify first, it'll keep your numbers from getting so large that it becomes really difficult to simplify the fraction later. 2 times 1 is 2, 7 times 3 is 21. So that would be your answer there. Now I just want to back up and go back to that earlier slide. Knowing that we know, here was my area model, and again, this is the part where you won't need to write anything down. But using what we know about multiplying, I can simplify here, and here, and here, divide out a 2, 1, and 2, and you can see that my product is in fact 1/2. And if I model fraction division, now, we haven't talked about this is the next lesson, but you have to make this improper first. 4 times 2 plus 1 is 9/4 divided by 1/2, which would be 9/4. Keep, change the sign, flip the fraction, simplify if you can, equals 9/2, and then this is improper, so you would divide that. 2 goes into 9 how many times? 4. 8 leaves us with 1, so 1/2. Excuse me. Okay, so I hope you can understand how using the model helps you represent the multiplication and division in a way that you maybe weren't aware you could. So write down any questions you have or use the question link on the website, and I will see you in class.